Okay, I mentioned the plants. The second key point about micropropagation that I wanted to mention is that the plants are grown in a very clean environment. The plants are actually grown in a sterile environment. You notice all the plants are being grown in containers such as these. On the bottom of those containers, we have something called the nutrient medium. This is basically, its most basic level, is a fertilizer solution that's providing all the nutrients the plants need to grow in these cups. We add a substance called agar that makes it gel up. It's about the same consistency of Jell-O. It's soft enough that you can stick little cuttings in there and without breaking them, but hard enough that it holds them up, so it gives them a semi-solid surface for those little plants to grow on. Aside from the nutrients that the plant needs, we also add a little bit of sugar in there because even though on these shelves in here where you saw it looks fairly bright in there, it's a lot less lower light intensity than natural sunlight outside. So we add a little bit of sugar also in here so the plants can grow and not grow well and not rely completely on photosynthesis. But because of that combination of sugars and nutrients in here, if we get any microbes in here, they usually take off and grow a lot quicker in the plants. This one's been contaminated with a fungus, probably a little fungal spore that got in there and just started growing. This one's got a bacteria growing in here. This is stuff we have to throw out. Even though these aren't necessarily plant pathogens that's going to attack the plant, they usually either choke out the plants because they grow faster or they keep the plants from getting enough nutrients and we get weak plants. So this all gets thrown out. But because of that, the environment inside these cups has to be sterile. So when we prepare this media, we actually have to cook it in a sterilizer, and we heat it up to fairly high temperature and pressure, and it kills all the microbes. And so it comes out as a liquid, and then it gets poured into these cups, which have also been sterilized in a special environment where we don't get any contamination in there. And then as it cools, it sets, and so it forms that gel in there. But that's sterile, and then also the plant cuttings that go in there have to be sterile. So when we're starting a new crop and bringing it into production, what we usually do is we'll take cuttings from a tree. In most cases, we want to start off with a very clean, healthy, disease-free plant. So a lot of new varieties, when they get released by a breeder at UC Davis or wherever the case may be, when he's got a new, say for example, a rootstock variety for almond trees, he releases it because it's got particular characteristics, whether it be disease resistance or adaptability to salts or whatever. It's been characterized and it's been proven to be a fairly good rootstock. That'll get sent to, in this particular case, Foundation Plant Services up at UC Davis. They test it for any known diseases that they can test for and for viruses. Once they know that tree is clean, that it's healthy, then they'll release material to the nurseries to start propagating and making trees to make available to growers. So we usually start off with material that's been tested for viruses and diseases. We'll take cuttings of that tree. We don't need a lot. We should take 10 to 20 cuttings of the new shoot growth on those. We'll bring them here. We'll do what we call surface sterilization. Basically, we wash them with a dilute bleach solution that kills all the microbes in that plant tissue. And then those little cuttings, we'll cut it up into little sections, nodal sections, so each one has a bud. We'll stick it on a nutrient medium and start it growing. The two most important things are to make sure that we've killed all the microbes on there so there's no contamination on that gel. And then we have to figure out what nutrients to mix in, a combination of nutrients to mix in that nutrient medium for that plant to grow well for us on. That's a lot of times very important. Each crop we do in here usually has its own combination of nutrients that we have to feed it with. So it takes a lot of trial and error sometimes for new things that haven't been done typically through this process. And all our media that we use here are proprietary, so we usually figure out what the plants need and kind of keep that to ourselves because it's a fairly key part of the business here. So those are the two important points. As far as the process itself, I mentioned the plants are sterile. The plants grow in these containers for about 4 weeks before they start getting a little too big for the container or almost reaching the top of the container, or they start running out of nutrients at about 4 weeks. So about every 4 weeks, all the plants we have in this facility have to be repropagated. You saw that grow room here we have here in the entrance. In that grow room, we have about 100,000 plants in there. In the 6 grow rooms we have in the facility, if they're all full, at any one time we'll have about 1 million plants growing in containers like this here in the lab. Volume-wise, we produce every year about 4 to 5 million plants for the nursery out of the lab. Each little container has 25 plants. So, and you see those black trays that they stack the containers on. Each tray has 12 cups. So each tray has 300 plants on it. So it adds up quickly. So it also lets us produce a large number of plants in a fairly small footprint.
question.
Yes.
So by the time, from where it starts to you get to the grower, how long is that?
Somebody, lady here's asking, from the time we start to the time it gets to the grower, how long is that? The process itself, when we first bring in cutting and get it established in culture and getting growing well for us, what happens is, I was just getting to that. About 4 weeks, these plants have been there about 4 weeks. They have to be repropagated. So we'll take them out of here. We'll cut them up. Each little node that has a bud will get cut into its own section, and each one becomes a new plant. So one little shoot in here might have 3 or 4 buds on there. Each bud will become a new plant. So when we first start out, we may start off with just a few plants. Every 4 weeks, we're multiplying it. So out of 1 cup, we may get 4 or 5 new cups every 4 weeks. We have to build up a certain amount of material in here before we take that plant into production. Once we have enough of that to take that into production, what happens is we have a certain amount of material that we're repropagating every 4 weeks, and we're maintaining it here in the lab. That becomes our mother stock for that crop. So it's always maintained here in the lab as long as we have that plant in production. And the extra material that we get after we maintain that certain amount, that gets taken out, and we'll cut the shoots, and instead of cutting them up into little pieces to make more, we'll keep the whole shoot, we'll put it on a different media that encourages rooting, and it's better for rooting, and we'll get that little shoot to root, and that becomes plant that gets sent to the nursery and grown out. Once we have something in production, every 4 weeks we can be producing plants to send to the nursery to get potted up and grown.
So does that already have the rootstock that you want on it, or does it have to go?
This is just the rootstock at this point.
This is just the rootstock?
Just the rootstock. And as you go through the tour, you'll see the progression of where we go from the rootstock, and it grows, and it gets budded, and so forth. What was I just going to mention? Oh, from the time usually when we have a new crop that we're starting in here, from the time we get those cuttings and introduce them into culture and start growing them, typically it's about 1.5 years before we have enough of that material to take it into production. It's not a fast process, but for fruit and nut trees, it's still fairly quick compared to if you're a typical nursery, you're getting cuttings and you're having to root those, grow a tree big enough to take more cuttings from that tree to make more mother trees. That can take several years. So this process is not fast, but in a lot of times it can be as fast or faster than the traditional methods for producing trees to make available to growers once the new variety is released.
With such a sterile environment, how do you think those pathogens got in there?
Let me tell you about the process itself. Obviously, you can't expose the plants to normal air outside because they'll get recontaminated. There's always bacteria or fungal spores pouring around in the air. You'll see the ladies doing propagation here. They're doing it in what we call, these cabinets here are called laminar flow hoods. The way those work is they have blower motors, blower fans in the bottom of the cabinet. They'll take in air through the bottom, and then they'll force the air from the back of the cabinet out over the work surface towards the worker. And what you see behind those metal grids there in the back of the cabinets are big HEPA filters. As the air gets pushed through those HEPA filters remove all the microbes out of the air. So you have a slowly flowing wall of air constantly moving across the work surface that's sterile. So that gives you a workstation environment where you can open up the cups and not get stuff out of the air back into the cups and contaminate those. All the plant material has to be handled with forceps, and you can see the ladies using the forceps and the scalpels that have been sterilized also. It gets cut up on little plastic petri dishes that are also sterile, so anything that touches the plant has to be sterile. That being said, there's always points where you can recontaminate it, and you have to be very careful, and our workers here have to be very well trained, and they have to understand that they can easily contaminate stuff with basically things you can't see, because you can't see those bacteria, you can't see those fungal spores. So if your forceps or scalpel touches anything that wasn't sterile, such as the inside of the petri dish, the plant, or the inside of the cup, if you touch something outside of those things, you've probably recontaminated your tools. So they're constantly re-sterilizing their tools, so they have several sets of tools that they work with. But there's a lot of different ways, because it's just, if you're good at it, you keep your plant material clean. We usually have well under 1% of our material in here that gets contaminated. But also, there's always a little bit of contamination. But we try to keep it at a minimum. And if we're doing a good job, we usually do. Yes?
Are the containers gas permeable? How do they get air exchange?
The containers, the lids aren't completely airtight. There is a little bit of gas exchange. They have like little knots to keep it from making a really airtight seal. So there's a little bit of gas exchange through the lid, but not enough that you can actually get microbes back in there. But if you look on the top of the containers, we also drill holes in the lids, and we put a special tape on there that has pores large enough to provide gas exchange, but small enough that microbes don't get through it. So that adds a little bit of more better gas exchange.